Right, and I know that in this triangle, this is a regular triangle, all the corners would be 60 degrees. So I could say that the tangent of 60 degrees is the opposite side, BD, divided by the adjacent side, 3. Solving this problem, you will find the length of BD. Now, you could use the formula that we just developed. The area of a regular polygon is 1/2 of the apothem times the perimeter. But in this case, probably it's just easier to say the area is half of the base times the height, half of the base times the height. And you will simply then multiply the base of 6 multiplied by the height you just discovered, which is BD. All right, so the area is 1/2 of the base 6, 1/2 of 6, multiplied by the height, which you found using the function above, tangent 60 equals BD over 3, and that will give you the area of the triangle. Let's move on now to number 3. Number 3 is a square in which they show me that the radius is 9. Okay, this time I do want to use the formula. Area is 1/2 of the apothem times the perimeter. Well, knowing that the radius is 9, we can solve for the apothem and we can solve for the perimeter. Okay, so I'd like to make some observations on this square. I labeled it ABCD. I said, okay, let AO be 9, that's the radius. And I pictured their OE, which is going to be the apothem. All right, so I drew that triangle. And so again, each problem you do, you're gonna probably want to draw a triangle, which is just part of the whole figure. All right. In this case, since the corner BAD is a 90-degree angle, then AOE is a 45-degree angle, which I've labeled right here. All right, so that makes this a 45, 45, 90 triangle, 45, 45, 90. And I want to remind you that in a 45, 45, 90, the sides are in the relationship S root of 2. S root of 2, right? And basically, S root of 2 is 1.4 times S. So the side across from each 45 is S units long, and the hypotenuse is 1.4 times either side. Knowing that, I can solve for OE, all right? The hypotenuse is 9 units long, and so the sides across from the 45 would be 9 divided by the root of 2. All right, 9 divided by the root of 2. So that'll give me the apothem, OE. It'll also give me 1/8 of the perimeter. Looking at the diagram way up above here, AE is 1/8 of the total perimeter. There are 8 lengths of AE, in other words. So in this case, once you solve for the apothem, you will also multiply that by 8 to find the perimeter. So I'll go back to my formula. I'm going to take 1/2 of the apothem, which I found by taking 9 divided by the root of 2, and then multiply that by 8 times that number, 8 times OE, which is the same length as 8 times AE, which is the perimeter. I'm going to multiply those two together to get my total area. Problem number 13 I'd like to explain also. Problem number 13 is an octagon. Problem 13 has 8 sides. All right. Again, what I would do is I would just make one angle here. What I did is I said, okay, I'm going to focus on just 1/8 of the octagon. I'm going to label it ABC, where B is the center point, and AC is part of the perimeter. Notice in this problem number 13 that each part of the perimeter is 11 units long. All right? Now, one of the first things I did is I tried to find out what is the angle. So if I drop the apothem, which hits the side at 90 degrees, that's what I did in this diagram here, I said, well, what is this red angle up here? In other words, what's 1/2 of the total central angle? So I said, well, there are 8 sides. If you take 360 divided by 8, you will find that each angle from here to here is 45. So half of that, this portion here, would be 45 in half, 22.5. If all of angle B is 45, then half of B, which is going to become critical as I use my trig functions, is 22.5. Okay, so I'm going to focus just a minute on how to find the apothem. BD is the apothem. From the center B straight down. Okay. D is that point right there. Is going to be the apothem. And AD is going to be, as I mentioned, I believe I mentioned that, half of 11. If the total AC is 11 in the given, then half of that is 5.5. So I can use the tangent function. The tangent of 22.5 is equal to the opposite side, AD, 5.5, divided by the adjacent side, BD, which is unknown. The tangent of the angle up here in red, this corner, is equal to the opposite side, AD, half of 11, divided by the adjacent side, BD, which will allow me to solve for the length of BD, the apothem. Once I solve that, I can take 1/2 of it multiplied by the perimeter. How are we going to find the perimeter? Well, each side of this octagon is 11. Each side is 11. I have 8 sides. If I take 8 times 11, I will find the perimeter. So if we take the perimeter multiplied by the apothem we discovered earlier, multiply that by 1/2, we will know the area of the polygon. Okay, with that, I wish you well as you do this assignment. Take your time. You're going to have to carefully study what are your central angles. For example, number 11, you're going to take 360 divided by 5 for your central angle. Number 12, 360 divided by 6. Number 13, I did with you. Numbers 15 through 20, you have to combine figures. For example, in number 15, you have a rectangle. You're going to take its area added to the area of a triangle. In number 16, you have 3 rectangles to add together. In number 17, you have a rhombus. You're going to have to add the area of the rhombus to 3 half circles. Number 18, you have 2 rectangles added to 1/4 of a circle. Number 19, you're going to have to take a square, the area of a square, subtract the area of a circle. Number 20 is kind of a neat problem. I would probably start by taking the area of the rectangle, 10 by 13, subtract the area of half of a circle whose radius is 5, and then add to that the area of the triangle whose base is 10, and you'll have to use the Pythagorean theorem to find its height perpendicular to the base. 9 squared is equal to 5 squared plus what squared? Once you find that unknown length, that will be the height of that triangle whose base is 10. All right, and by the way, the answer for 20 is somewhere between, it's more than 100 and less than 200, just to give you a hint there. If you have questions, you're certainly welcome to call me. I often help students in geometry. You can call me anytime. especially in the morning, is helpful. 492-2823. You may call me before 4 o'clock any day, and I'm very happy to help you on these difficult assignments. Thank you.